All right, so we're diving deep today
Yeah.
into scaling systems and React. It's
Okay.
kind of like getting ready to build something huge,
hmm
and you want to make sure it doesn't just, fall apart when a ton of people start using it.
You want to make sure it can handle the traffic
Right,
for all
exactly.
those users.
And keep things run smoothly
They're
to
nappy. Yeah,
keep it
okay.
snappy, for sure. I've got a whole stack of resources here for us.
Oh, wow.
A system design primer from GitHub,
Nice.
some React interview questions that look pretty tricky,
Oh, yeah, those can be tough.
some tips straight from the React docs on performance.
Always good to have those.
Yeah, and even some insights from patterns.dev.
Oh, nice.
We're going to try to sort through all of this
Sounds like a plan.
so you can walk away feeling confident about this whole thing.
Yeah, that's the goal. Help you ace those interviews and build awesome stuff.
Right, exactly. So think of it this way.
Okay.
It's like we're planning a city, not just a single house.
That's a good analogy.
You got to have a strong foundation.
That can handle growth. Right.
Yeah, otherwise those skyscrapers might start sinking.
Exactly. So before we get into the concrete and steel,
Yeah.
let's talk about some basics. This system design primer
Okay.
starts off with performance versus scalability.
Right.
I feel like these terms get thrown around a lot.
They do. What's the difference, really?
Well, they're often used interchangeably, but they're distinct.
Okay.
Performance is all about how quickly your system can respond to a single user.
Mm-hmm.
So it's about speed and efficiency.
Okay.
Scalability, on the other hand, is how well your system handles a lot of users
Mm-hmm.
and increasing amounts of data.
So like growth.
Yeah.
Growth, exactly.
Okay, so if my app is taking forever to load, but it's just me using it,
Right.
that's a performance issue.
That's performance.
But if it loads, fine for me.
Okay.
But then it crashes when my friends try to use it,
Uh-huh.
that's more of a scalability problem.
Exactly, you got it.
Okay, cool.
And to make things even trickier,
Oh, no.
we've got two more terms.
Latency and throughput.
Latency. Everybody hates waiting.
I do. It's the worst.
So I know latency is about delays,
Uh-huh.
but what about throughput?
So latency is the time it takes for a request to be completed.
Okay.
That lag that you were talking about.
Gotcha.
Throughput is all about how much your system can handle
Okay.
in a given time frame.
Mm-hmm.
Think of a highway.
Okay.
Low latency means cars are moving quickly.
Okay.
High throughput means a ton of cars can be on the highway at once
but
without causing a traffic jam.
So a high-performance system has low latency
Yeah.
and processes requests quickly,
Right.
and then a highly scalable system can keep that speed up,
Exactly.
even as the number of users and data increases.
Precisely. It's about finding that balance.
That delicate balance.
Yeah, and now ready for two more concepts that can make or break your system.
Oh, gosh. I'm a little scared, but
Yeah.
lay it on me.
Availability versus consistency. So imagine a huge online game where everyone needs to see the same info.
Okay, like who scored the winning point or something.
Exactly. You need consistency,
Gotcha.
but the game also needs to always be up and running.
Right, even if there are server problems.
Right. Availability is key.
Availability, got it.
That's a perfect example, actually,
Okay.
of the tension between availability and consistency.
Okay.
In the distributed system like that online game,
Yeah.
you can't have perfect consistency and availability at the same time.
Oh, no.
It's almost impossible.
Okay.
And your system design primer mentions something called the CRP theorem,
Okay.
which explains this trade-off.
Okay, so what is that?
It says that you can only have 2 out of 3 guarantees in a distributed system.
Okay,
Those are consistency. So everyone sees the same data,
got it.
availability.
Hmm.
So the system is always working,
Mm-hmm.
and partition tolerance,
Okay.
which means the system works even when there are network problems.
So you're telling me I can't have it all?
Well, you can't avoid network problems entirely, can you?
That's true.
Partition tolerance is just a fact of life when
Yeah.
you're building these complex systems.
Mm-hmm.
So you have to choose.
Okay.
Do you want to prioritize consistency,
Okay.
which means everyone sees the same data, even if there's some downtime?
Mm-hmm.
Or do you prioritize availability,
Gotcha.
keeping the system running even if the data is momentarily out of sync?
So in that online game example,
Yeah.
if you choose consistency,
Mhm.
everyone sees that winning point at the same time,
Yeah,
but the game might freeze for a few seconds if there's a network glitch.
exactly.
And if you go for availability,
Okay.
the game keeps running smoothly,
Mm-hmm.
but maybe some players see a delay in the score update.
Right. It's all about trade-offs.
That is tricky.
It's about understanding those trade-offs
Right.
and choosing the right approach for your system
Got it.
and your users.
Okay, so let's shift gears a bit
All right.
and talk about the classic database debate, SQL versus NoSQL. Imagine building a library.
Okay.
You have two choices.
Right.
Organize everything meticulously with the Dewey Decimal System,
Okay.
that's SQL,
Mm-hmm.
or create more flexible sections for different types of books.
Yeah, that's more like NoSQL.
NoSQL, right?
Yeah.
That's a helpful way to think about it.
Yeah, it is.
But how do I know which one is right for my project?
Right.
It seems like there's no clear winner.
Well, that's because there isn't one.
Oh,
It
okay.
really depends.
Yeah.
SQL databases are great for structured data, things that fit neatly into rows and columns,
Okay.
like financial transactions or customer records.
Okay.
They enforce strict relationships between data.
Uh-huh.
NoSQL databases are much more flexible.
Okay.
They can handle tons of different data types,
All right.
from key value pairs to complex documents.
So SQL is like a really organized library with strict rules.
Yeah.
And NoSQL is like a bookstore with different sections.
That's a good way to put it.
Cool. Okay, so another term I keep seeing everywhere is caching. Right.
Is that like storing the most popular books right by the entrance?
You got it.
Oh,
Caching is all about storing frequently accessed data
okay.
in a place where it can be retrieved super fast,
Got it.
instead of going all the way to the database every time
Yeah.
you keep those popular books readily available.
I like that analogy.
Good.
I remember seeing something about Memcached and Redis.
Yeah.
Are they like super speedy librarians or something?
That's a great way to think about it.
Okay.
They are in-memory data stores,
Okay.
meaning they store data in RAM
Okay.
for really fast access.
So they can speed things up.
It reduces the need to query your database constantly.
So they act as like a temporary storage
Yeah,
for that in-demand data.
exactly.
But where do they fit in?
Right.
I see things about client caching, CDN caching, and server caching.
Yeah, caching happens at lots of different levels.
Okay.
Client caching happens on the user's device,
Okay.
so they don't have to keep re-downloading the same stuff.
CDN caching uses a network of servers
Yeah.
to deliver content to users around the world.
Right.
And server caching happens on your web servers,
Gotcha.
storing database results and other computed values.
Wow, so it's caching all the way down.
It is.
So different types of caching,
Yeah.
depending on the data and where it needs to be accessed from.
Exactly.
Okay, that makes sense.
Good. And there are also different caching strategies, like cache aside,
Mm.
right through,
Okay.
and right behind.
Gotcha.
But before we get into that,
Okay.
let's talk about another key concept,
All right.
microservices.
Okay, so are microservices like breaking down that massive library into smaller,
You got it.
like specialized reading rooms?
That's a great analogy.
Okay.
Microservices are all about dividing a large, complex system
Okay.
into smaller, independent services
Okay.
that can work together.
So instead of one giant application trying to
Mhm.
do everything,
Yeah.
you've got this network of smaller services,
So you got-
each focused on one specific task.
Yes, so instead of one overworked librarian,
Right?
you have a team of specialists.
That makes sense.
Yeah.
Why is this approach so important for building scalable systems, though?
Well, for one, it makes it easier to scale individual parts of your system.
Okay.
Let's say your online store suddenly has a lot more traffic
Okay.
to the product pages.
Uh-huh.
With microservices, you can scale up that product catalog service
Okay.
without affecting other parts of the system.
So it's like adding more librarians to the busy reading rooms
Exactly.
without disrupting the whole library.
Yeah,
That's pretty neat.
it is. And another benefit is that microservices make development and deployment much more agile.
Okay. How so?
Smaller teams can work on different services at the same time,
Okay.
speeding up development.
Mm-hmm.
And if one service has a problem,
Right.
it's less likely to bring down the entire system.
That makes sense.
It's about building resilience
Gotcha.
and flexibility.
Okay, so microservices are like a team of expert librarians,
They are.
each focused on their own area,
Yeah.
making the whole library run smoothly
Exactly.
and efficiently.
You're getting it.
I'm starting to see how all these pieces fit together.
That's great to hear.
Now let's talk about React.
All right.
This JavaScript library that's perfect for building
Yeah.
dynamic and interactive user interfaces.
It is.
I've been looking at these React resources,
Yeah.
and one term keeps popping up.
What's that?
Virtual DOM.
Right.
Is that like a blueprint for the library we're building?
You're on the right track.
Right.
The virtual DOM is a lightweight representation
Okay.
of the actual DOM,
Mhm.
which is the structure of your web page.
Yeah, okay.
React makes changes to this virtual representation first,
Okay.
instead of directly manipulating the actual DOM,
Mm-hmm.
which can be slow
Yeah.
and resource intensive.
Okay.
Then it figures out the most efficient way to update the actual DOM.
So it's like streamlining the building process.
Yeah.
Instead of constantly like tearing down and rebuilding walls,
Right.
React is planning out those changes
Mm-hmm.
on a blueprint
Exactly.
and making those changes strategically.
You got it.
that makes sense.
Good.
So now let's talk about React components.
Okay.
I see them described as building blocks,
They are?
like the bricks and mortar of our library.
Yeah, what's the deal with that?
What's the deal with those,
Yeah.
right? So components are like modular building blocks
Yes.
that let you break down your user interface
Okay.
into smaller reusable pieces.
That's right.
So you could build a book component
Right.
to display info about a single book,
Uh-huh.
a shelf component to arrange those books,
Yes.
and a library component to bring it all together.
Got it.
So instead of building the whole library from scratch,
Right.
you're creating these prefabricated sections
Yeah.
that you can assemble and rearrange.
It's pretty clever, right?
That is really clever.
It is.
And the best part is they're reusable.
Yeah.
So you can use that same book component
Mm-hmm.
on different pages of your app,
Mm-hmm.
or even different projects altogether.
Exactly.
That saves so much time and effort.
It does. It's a game changer.
Okay, so I've noticed some debate in these resources
Oh, yeah.
about hooks versus classes in React.
Right.
Is this like a battle between the old guard and the newcomers?
It's a common discussion in the React world.
Okay.
But before we jump into that debate,
Okay.
let's quickly recap what state management is
Okay.
and why it matters.
Sounds good.
Imagine you have a counter in your library
Okay.
that keeps track of how many books are borrowed.
Mm-hmm.
That counter needs to be updated
Right.
every time a book is checked out or returned.
Yeah.
That's where state management comes in.
Okay.
It lets you manage and update data that changes over time
Okay.
within your components.
So state is like the data that keeps track of everything happening in our library.
Precisely.
Like how many books are borrowed,
Right.
which shelves are, things like that.
Exactly.
Got it.
So classes and hooks
Yeah.
are two different ways
Okay.
to handle state and other events
Okay.
within your components.
Right.
Classes are the traditional approach,
Yeah.
a structured way to define a component's behavior.
Mm-hmm.
Hooks are newer.
Okay.
They let you use state and other features
Right.
without writing traditional class components.
So hooks are kind of a more modern approach
Yeah.
to managing state,
Yeah.
a more streamlined way compared to classes.
That's a good way to put it.
Okay.
And there's a lot of debate about which is better.
Yeah, I can imagine.
Easier to use, more efficient.
Right. Is there a right answer?
Well, like a lot of things in software development,
Yeah.
there isn't a one-size-fits-all answer.
Okay. That makes sense.
It depends on
Yeah.
your specific needs and the project.
Okay. So I'm sensing a deep dive into the pros and cons of each coming soon.
You bet.
All right. I'm ready.
But before we get lost in that,
Okay.
let's wrap up this part with one last crucial topic.
Yeah. What's that?
Performance optimization in React.
Performance optimization. Okay.
Yeah.
Because even the most impressive library is useless if people can't find the books they need.
Exactly.
Yeah.
Right?
It's got to be fast.
It's got to be fast.
Cool.
Exactly.
Yeah.
I know React is generally known for its speed,
It is.
but I bet there are ways to make it even snappier.
You're right. There are always ways to optimize performance.
Cool. Okay, so what are some techniques I
Mhm.
can use to supercharge my React apps?
Well, first,
Okay.
your React documentation mentions using the production build.
Okay, the production build.
It's optimized for speed and efficiency.
All right.
It strips out all the debugging tools and extra code
Gotcha.
that you might use during development,
Okay.
but that slows things down in a live environment.
So it's like streamlining for peak efficiency.
Exactly.
Got it.
It's like switching from a practice session
Yeah.
to the main performance.
Okay. What else can I do?
Another powerful tool is the React Dev Tools. React Dev Tools.
It gives you X-ray vision into your app's performance.
Oh, wow.
You can see which components are causing problems.
So you can pinpoint the slow sections
You got it.
and figure out how to make them more efficient.
Exactly.
That seems really useful.
It is. It's like having a detective for performance issues.
Okay. I also remember seeing something about virtualizing long lists.
Right.
What's that all about?
That's for when you have tons of data,
Okay.
like a library catalog with thousands of books.
Mm-hmm.
Imagine trying to show all those books at once.
Yeah.
It would take forever to load.
Yeah.
Virtualization only renders the visible portion of the list,
Oh, okay.
so it speeds things up.
It's like only showing the books that are actually visible to the user.
Exactly.
That's really clever.
It is. It's a great way to optimize performance.
So now switching gears a bit.
Okay.
I've been curious about these design patterns
Why?
mentioned in the patterns.dev resource.
Yes.
Are they like blueprints for building specific sections of the library?
You're close.
Okay.
Design patterns are reusable solutions
Okay.
to common problems in software development.
So they're like tried and true
Yeah.
architectural plans that have
Okay.
worked well in the past.
Yeah.
So instead of reinventing the wheel,
Right.
I can look to these patterns for guidance.
You got it.
They're like a collection of best practices
They are.
that are ready to use.
Yes, they are.
Okay. I'm sold, but there are so many of them.
Yeah.
Where do I even begin?
Well, patterns.dev is a great place to start.
Okay.
It covers a wide range of patterns,
Okay.
including ones for front-end development with React.
Perfect. I'll definitely check that out. But can you
I-
give me an example
Sure.
of how a design pattern might be applied?
Yeah.
A real React app.
Okay, so let's take the container presentational pattern.
Okay. The container presentational pattern.
Imagine building a product listing page
Mm-hmm.
for an online store. This pattern separates the logic
Yeah.
of fetching and filtering products
Okay.
from the presentation of those products.
Okay, so the container component is like the behind-the-scenes librarian
That's right.
fetching the products from the database.
Yeah.
And the presentational component is like the display shelves.
Yeah, exactly.
Showcasing those products to the user.
You got it.
That's a great way to think about it.
It is.
And the separation makes your code more organized,
Yes.
reusable,
Mhm.
and easier to test and maintain.
It does.
I can see how that would be really helpful,
Yeah.
especially as the application grows
Absolutely.
and becomes more complex.
And there are tons of other design patterns out there
Oh, wow.
to solve different problems.
Okay, I'm really starting to appreciate the power of these design patterns.
That's
They're like a secret weapon
They are.
for building really robust software.
That's right.
But, with all this talk about scalability and performance
Mhm.
and design patterns,
Yeah.
building a large-scale app seems pretty daunting.
It can be.
Are there any, common pitfalls
Yeah.
or challenges that I should be aware of?
Yeah, for sure.
Okay.
One common pitfall is over-engineering,
Over-engineering.
which is like building a library with all these fancy features
Well,
that
yeah.
no one actually needs.
Yeah.
It's easy to get caught up in the latest tech,
Right.
but sometimes simple is best.
Keep it simple, stupid.
Exactly.
I'll try to remember that.
Good. What other challenges are you worried about?
Well, maintaining consistency
Right.
as the app grows.
That's a big one.
It's like making sure all the reading rooms in the library have the same rules
Uh-huh.
and a cohesive design.
Right, as you add more features and
Right.
developers.
And in components.
Yeah, it can be hard to keep everything working together smoothly.
Yeah, so it's not just about building individual components. It's
Yeah.
about making sure they all play nicely together
Exactly.
and create a good experience for the user.
That's right. And that's where clear communication comes in,
Okay.
and well-defined coding conventions,
Okay.
and a good testing strategy.
Those sound like crucial ingredients for success.
They are. What about security? Are you concerned about that?
Yeah, security is definitely a big concern,
Yeah, it should be.
especially with sensitive user data.
You need to be aware of vulnerabilities
Okay.
and take steps to protect user data.
So it's like installing a security system
Exactly.
to keep everything safe.
Right. This includes strong passwords,
Yeah.
encrypting data, and
Mhm.
following best practices.
So security is not something to be taken lightly.
It's not.
Okay, we've talked about performance optimization, but are there any common bottlenecks
There are.
that I should watch out for?
Yeah,
It's like identifying the high traffic areas in the
Yeah.
library that tend to get congested.
exactly. One common bottleneck
Yeah.
is inefficient database queries.
Okay, database queries.
If your queries are slow,
Okay.
they can really impact performance.
It's like a librarian who takes forever to find a book, slowing everyone down.
Right. So you want to make sure those queries are quick
Gotcha.
and efficient.
Okay, another bottleneck.
Yeah,
Excessive DOM manipulation.
that's another one.
That's like constantly rearranging the bookshelves.
It is. It creates chaos.
Yeah.
React tries to minimize DOM updates,
Okay.
but you can still end up with slow performance.
Right. So I need to be careful.
Yeah. Be mindful of how your components
Okay.
interact with the DOM
Okay.
and optimize them
Got it.
to avoid those unnecessary re-renders.
So striking a balance
Yeah.
between a dynamic experience
Mhm.
and keeping those DOM updates to a minimum.
Exactly.
Okay, I'm getting it.
Good.
Now let's tackle the big one.
Okay.
Scalability.
Scalability.
What are some of the biggest challenges
Yep.
when scaling a web application
Right.
to handle millions of users?
Well, scaling to handle that much traffic
Yeah.
can be really tough. It often involves distributing your application
Okay.
across multiple servers, databases, and
Mhm.
caches.
All right.
And this introduces new complexities
Yeah.
in terms of data consistency,
Yeah.
load balancing,
Mhm.
and fault tolerance.
So it's not just about building a bigger library.
Right.
It's about creating a network of libraries that can
Mhm.
handle a global influx of visitors.
Exactly.
That's a lot.
It is.
And it requires careful planning,
It does.
a well-thought-out architecture,
Yeah.
and a deep understanding of these distributed systems.
You got it.
This is really giving me a sense
Mhm.
of how intricate building a scalable web application can be.
It is intricate.
It's like building a technological marvel.
You could say that.
But it's also inspiring
It is
to
inspiring.
see how all these pieces come together
Yeah,
to create a system that can handle such massive scale.
it's amazing.
Yeah, and still provide a seamless user experience.
It is building systems that can handle that kind of load. It's a fascinating challenge.
It is.
It takes technical expertise, creative problem solving,
Yeah.
and a passion for pushing the boundaries.
I love that.
It's exciting stuff.
It is. It really is. It's
Yeah.
mind-blowing to think about
Yeah.
all the moving parts
It is a lot.
involved in building something like this.
Yeah.
So where does system design fit into all of this?
Right.
Is it something you do up front before writing any code,
Yeah.
or does it evolve over time?
Ideally, it's an ongoing process.
Okay.
You need a vision for the architecture from the start,
Okay.
but flexibility is key.
So it's not about creating a perfect blueprint that
Right.
can never change.
It's more about a foundation
Okay.
that can adapt and grow.
So it's an ongoing conversation
Yeah.
between developers,
Mm-hmm.
product managers,
Yeah.
and stakeholders.
Exactly. As your app grows, you'll encounter new challenges,
Right.
and your system design should evolve.
It's like starting with a blueprint,
Yep.
but being open to adding new wings as the collection expands.
Exactly. And just like a well-designed library is a joy to visit, a well-designed app is a pleasure to use.
That's a great point.
Yeah.
We can get caught up in the technical stuff,
It's easy to do.
but it's all about the user in the end,
It is.
right? Choosing the right database,
Mm-hmm.
optimizing those React components.
Yeah.
It all comes down to creating a great experience.
Absolutely. We can get lost in the weeds,
Yeah,
but we can't lose sight of the big picture.
right.
We're building apps that are not only functional,
Yeah,
but also delightful to use.
right.
It's where tech and human-centered design meet.
I love that.
That's a sweet spot.
It is. This deep dive has been amazing.
Yeah.
We've explored so much.
We have.
From scaling systems
Yeah.
to building with React
Uh-huh.
to the art of creating really elegant software.
It's been quite a journey.
It really has.
But remember, host speaker.
This is just the beginning of your journey into building these awesome web applications.
It is. There's so much more to learn and explore.
It feels both exciting and a little overwhelming.
I get it. It's a lot to take in.
It is, but I'm feeling inspired to dive in.
That's the spirit.
And I can't wait to see what you build with these insights.
Remember, the key is to keep learning and experimenting.
Okay,
And don't be afraid to challenge yourself.
gotcha.
And don't forget about the developer community.
Right.
There are tons of people out there who are passionate about this stuff,
That's good to know.
and they're always willing to help.
It's comforting to know we're not alone on this journey.
You've got a whole community behind you.
So on that note,
Yeah.
we'll wrap up this deep dive into scaling systems and React.
We hope you enjoyed it.
Yeah, thanks for joining us.
And happy coding.
Yeah.
It is a lot to take in.
Yeah, but it's exciting to
Yeah.
think about all the possibilities.
It is.
And, it really does feel like we're constructing a digital masterpiece. It's a good way to put it.
It is. So I'm curious,
Yeah.
where does system design fit into all of this?
Right.
Is it something you do up front
Go.
before you even write any code, or does it kind of evolve as you go?
Ideally, it's
Yeah.
an ongoing process.
Okay.
You start with a solid vision for the architecture,
Okay.
but you got to be flexible.
Yeah, because things change.
You do?
Requirements
Yeah.
change.
New challenges pop up.
Right. So it's not about creating this perfect, unchangeable plan.
No, it's more like a foundation
Okay.
that you can build on and adapt.
So it's more like a conversation
Exactly.
between developers,
Yeah.
product managers,
Mhm.
and stakeholders.
Right. And as your app grows,
Yeah,
you'll hit new roadblocks.
right.
And your system design needs to be able to handle that.
It's like starting with a blueprint for a library,
Okay.
but being open to adding new wings
Mhm.
or renovating spaces
Exactly.
as things evolve.
You got it. And just like a well-designed library is a joy to visit. Yeah.
A well-designed app is a pleasure to use.
That's so true.
It is
We can get so lost in the technical details.
easy to do.
But we have to remember,
Yeah,
it's all about the user at the end of the day.
it is all those choices we make.
Right.
They all come down to the user experience.
Exactly. Whether it's picking the right database or optimizing those React components,
Yeah,
it all comes back to that.
it does. It's about making something that people actually enjoy using.
Well said. I think this deep dive has been incredible.
Me too.
We've covered so much ground,
Yeah.
from scaling systems
Yeah.
to building with React
Mhm.
to creating truly elegant software.
It's been quite a journey.
It really has, and I feel like
Yeah.
this is just the beginning.
It is the beginning of your journey.
Right.
There's so much more to learn.
So much more to learn. I'm feeling inspired
That's great.
to keep diving deeper.
I love that.
And I can't wait to see what you build.
Me neither. Remember, just keep learning, keep experimenting, and keep challenging yourself.
Don't be afraid to make mistakes.
Exactly. And don't forget about the community.
Right.
They're there to help.
It's nice to know we're not alone in this.
You're definitely not.
So on that note,
Yeah.
we'll wrap up this deep dive
Sounds good.
into scaling systems and React.
It's been fun.
It has. Thanks for joining us.
And happy coding, everyone.